All right, cool. Good thing I remembered that. All right, so we just went through our knowns. Now, can somebody? Oh, they're okay. They're just walking by. Okay, first question. We don't know how to do this yet, so I'm going to show you how to do it. But the first question is, what is the appropriate array size and orientation to limit our generator usage to 5 times per month for the worst winter case? So what does that mean? That means that the homeowner doesn't want the generator to turn on more than 5 times a month. So the most the generator would turn on would be when? During
December.
Yeah, December, the worst month, worst case month, maybe January, but the darkest month. So we have to figure out how to do that. Now, first thing that we need to do is we need to go back to Moodle, and you need to download these two Excel sheets. You have this off-grid array sizing tool and PV watts hourly consolidation. So you're going to want to download both of those. So we'll use those in a second, but we need to calculate our battery bank size. Okay, so how would we do that? Yeah, carefully. Yeah, so we have the DC kilowatt hours. So how do we get to amp hours? So 4,000 watt hours divided by 48 volts, then you get amp hours. So can someone do that for me? Give me the amp hours.
$83.3.
4,000 watts divided by 48.
That's what I did here.
And what is it?
83.3.
83.3. Oh, okay, that's per day. But remember, we want 3 days of autonomy. So multiply that by 3.
250.
250. 250. Now, we don't want to discharge more than 70%, so that's when you would divide by 0.7. Divide by 0.7.
So 357?
357. So let me just write down what I just said. Oh, so I hit a bunch of dry erase markers, and now they're gone. I thought I hid them so well. Dang it.
It was Dr. Einstein, I know it. I played Rico. I also played Rico.
Shoot.
Yeah.
Tam's here? Dang it. I guess I'll just do it here. I guess I should do it here anyway because I'm recording. All right. We'll start a blank thing here. Blank notebook. New notes. This is definitely not blank. All right, classwork. I'll label that later. All right, so we had 4,000 watt hours per day, right? That was what was given. And we're trying to find the battery bank, what battery bank size. So we know we want 3 days of autonomy. So this is a per day situation. So you're going to multiply this value times 3 days. This is basically what we did in the Excel sheet, okay? Except we have the total watt hours per day already. So that'll give us, what, 12,000? watt hours divided by our 48 volt bank. What was that again? I'm sorry. 250 amp hours. All right. And then we want to make sure that we don't discharge more than 70% of the bank. So we're going to divide it by 0.7, 0.7. And so then what does that equal? 357. No, you're trying to oversize it. Yeah, so you don't want smaller than 250, you want larger. So because we want to oversize our battery bank so that we have an excess so that we don't discharge it more than 70%. So what was it? 257 or 357? Okay, I heard 257. That's why I was looking at it kind of weird. It's like, no, that can't be right. All right, so now we have our bank size, meaning the capacity. Okay, cool. All right, so let me flip back here. Okay, so now we've got our bank size, max appliance, temperature. Okay, so what I want you to do now is I want you to go to the website PV Watts really quick. PV. Okay, so Olympia, let's all type in, let's decide, are we going to type in the title Olympia or the zip code, because somehow you get different, okay, so 98501. 98501. All right, and then 98501, go. All right, do you have the same latitude and longitude as I do? Okay, and confirm. Now, I'm an outsider to the joke. Okay, so I want to make sure that you guys know where we're going here. So that stuff I had you download, let me open up PV Watts hourly consolidation. Open that guy up. Because what we're going to do is we're going to download the hourly data from PV Watts, and we're going to consolidate it. So remember the PV Watts data kind of looks like this right here, this area. So this spreadsheet consolidates, it consolidates all of these rows into your daily energy yield for each month. So day 1 of January, 996. And so that goes down all the way to 31 days, and of course February has 28. Okay, so that is your AC watts output. Okay, so we're going to use this, and what we'll do is we need to go back to our PV Watts that we just opened up, and we're basically going to use these spreadsheets and scale from a 4 kilowatt system. Now, that doesn't mean that ours is going to be 4 kilowatts, but we need to have some base to scale from. So when you're going to use these spreadsheets, you want to start with the 4 kilowatt system. So you're going to leave this here, okay? And we'll just leave module type as standard. We're just going to do a fixed open rack type. We're going to take the losses down to 0, okay, if you can. And then we need to figure out the best tilt. Now, we already kind of figured that out, right? For south facing, we did it on the first week. For your lowest month. Okay, so for December, does anybody remember? I think it's 36. Does somebody want to flip back? 36. 57 would be for the summer. Okay, 36. Cool, 36 would be our tilt. And we're going to say south facing because that's ideal. Because remember, it says that we have a flexible orientation. So now, if we go into advanced parameters, we want to leave everything the same except our inverter efficiency. We want to make that as high as we can because we're actually going to take that into account later. So I don't think it'll let you go any higher than like 99.5. Can't put 100 in there as far as I remember. It may not even let you do it. Oh yeah. 99.5. So here, make sure that these match for you guys. Okay. So now I'll go ahead and go to the next tab there. And you got an error? Oh no. Looks like January is our lowest producing month. 192. Okay, that's fine. So then we're going to go ahead and download our hourly data from this. It's probably a good idea to save that data somehow, just in case. Just maybe. I'm going to dig out my mouse here. I feel like I'm going to need it. Okay. So now, what we need to do is we need to take this big chunk of data that we just downloaded, all of it, the whole thing, not including the titles. Okay. And well, you can use the trick where you highlight the top. So you can go up to the top, highlight the top, kind of like what I did. So like this. And then you can scroll all the way to the bottom. And then you can press Shift, hold down Shift, and press the bottom right-hand corner of your data, and it'll highlight all of it. And then I'm going to copy it. Yeah, I can keep the totals. Copy it. And then we need to go to the consolidation sheet. And we'll paste it over at the top of those numbers that are already there. And you'll notice that your yields are going to change because those are just sums of the different columns. James.
The type of document you save,
Where did you say that?
PV watch hourly matter, because I'm looking at it, and what's to auto-define itself as a comma-defined,
The Excel sheet.
comma
Save it as an Excel work.
A CSV?
Yeah.
Replace it?
I think that's okay.
That works, or you can
You gotta highlight
save
all
it
that.
as an Excel.
Yeah,
I was wondering if you highlighted it, you included the totals?
I did. And I just pasted it right over the top.
What could you push control B?
By the way, the guy that invented control paste because he just died today.
Oh, yeah.
Hold on. Cut paste.
All right. How are we doing? Everybody with me? Hmm.
What is your total value?
For which month? What? Where are you looking?
Which one's the two lowest numbers of this entire thing? The reason why is because we can just compare them.
Right. So you mean the total for each month? Right. December and January. January smaller. So that's our worst month.
Our best. Why?
All right. So once you're here, what you need to do is you need to copy your January, which should be the smallest yield, that whole column like that. So copy that.
Starting from the first number?
Starting from the first number, not the yield thing, but the first number. And after you copy it, you need to go over and open up your off-grid array sizing tool, which is the other thing I had you download. You can enable the editing. Notice that this column right here in your off-grid array sizing tool looks an awful lot like what you just copied. I mean, maybe not exactly, because you have different numbers, but what you'll do is you'll just paste over the top of those DC watt-hour yield numbers. You want to right-click and just paste the numbers, not paste the actual, yeah. Okay, so it should look something like this.
That works. Did anyone have any problems?
Yeah, how's everybody doing? Horrible, terrible.
Did it work for you? So I just copied all the chat.
Okay,
Wait, what?
so you're a few steps behind.
Control G. Just what?
Okay, so you got that there. Okay, so just turn up over here to January, copy these numbers, with the exception of that one. Yeah. See that? All right, and go and open up the other spreadsheet. Yeah.
Mine was,
far right of the
You should have some. Jewel sausages in there, come on.
Because so which one was the one you just done?
Why did I not change it?
Oh, yeah, no, you should do that, that's a good idea. Yeah. Hey, that's a really good point, actually, that Megan brought up. you may want to, so you can keep track of what you're doing, because I can tell you you're probably going to do this multiple times if you're doing especially the graduate stuff. You may want to go to your hourly consolidation and make sure that this information matches what you download, because what you downloaded is are the parameters. Here are the parameters that this data is from. So you may want to copy this as well over to your consolidation, because this stuff is for another thing. Just a thought. Just a thought. Yeah, just so that you know. So you're going to copy from your downloaded PB Watt stuff, this stuff. So I'll do it. Copy, and then go over to my PB thing and paste it. It has an extra thing in there. Yeah, well, you're right. I'm just going to add, yeah, there are 2 extra cells. Well, I'll just copy what I can.
Which one are you on?
Well, I'm going to copy the first 14. This is the one you downloaded. I'm going to copy that. And then I'll go over and put it in the consolidation. There. Just so that we can keep track of what we're doing. All right. So the top of this is important. All of this information. It's all going to look familiar, actually. Depth of discharge. This you won't change. It's basically going to give you the amp hours, the lowest amp hours that you want to see in your battery. So, for example, you said that your battery bank is 100. Okay, well, I mean, that's what this says. We're going to change it, but 100. 30 amp hours is the lowest capacity that you're going to want discharge to. Okay, so this number changes when you change your bank size. So you don't do anything with this number, but you'll need to reference it when you're doing something else. Okay, so, okay, unshaded. So remember that in the assignment it said there was no shade. So this would be 100%. Let's change that to 100%. So this guy, 100%, meaning no shade. Oh, that's 1,000%. Whoa. All right. Charge efficiency. You can actually look at the little notes. This includes any kind of efficiency, wiring loss, battery charge and discharge loss. It's all kind of baked into this number right here. So we're just saying charge efficiency is 75%. Your battery bank size, we calculated that just now. And we said 357. Now, here's the thing. Are you going to be able to buy a 357 amp hour battery bank? Of course, exactly that.
I custom made it in my lab. You'd be surprised.
So you'll likely have to buy like a 351 or a 400 or whatever. So what we should do is let's go ahead and go to wholesale solar. So let's go open a new internet app. Wholesale solar.
You're above what?
Good question. You can round down, because what's going to happen is you're going to have to compensate that by adding maybe more panels.
Okay.
So you can actually, it's a give and take type of relationship. But that's a really good question. So we need to go to all products and go to battery banks. top picks, blah, 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 blah. Shop all battery banks.
Said you would add more solar, but I thought that the battery bank was required for 3 days without any solar.
Yeah. Kind of. You have a very good point. Now let me think about this for a second. So you probably would get a little bit less of that out. You probably would get slightly less than 3 days. So you're right.
What if you went on the higher side and did like 360?
Then you definitely get the 3 days.
Okay.
Yeah. Okay, so let's see. So we want to go not lithium because it's like 2,700 or 27,000. Excuse me. Go big or go home. Let's go down to flooded lead acid, 48 volts. So the lowest one there is 430 for 2,859. That's 48. If you go to view all batteries, here's the absorb glass mat. That'd be okay. That's 220. That's lower than we want. I went to all products, then I went to battery banks. Then I scrolled down and it says shop all battery banks. Absorbed matte glass, 250, 415. That's really big. Oh yeah, flooded lead acid is definitely the cheapest. 5.
I just use these to power my flashlights.
All right, so you can see that 440 is probably the one. Oh yeah, what's the price difference?
$3.95.
There's 430. Which one? Let's do the 415.
Absorbent glass.
Mm-hmm.
Oh, we need 48 volts.
Yeah, we do.
Oh,
Never mind. JK. All right. All right. 415 over here.
yeah, but that's 4800.
Oh, shoot. You're right. Haha. Never mind. Flooded lead acid, 48 volts, 430 amp hours, 2,859. That's it. Okay. Now, you will have to replace this probably in 7 years. So, yikes. You have to buy them all again. But it comes with cables. At least it comes with cables. They did that for us at least. So, okay, so 430. Let's go up here. No, wait. Let's go to where are we at? This one. 430. So battery bank size, 430 amp hours. Okay. And so our depth of discharge value is 129, meaning our amp hours cannot dip below 129. Okay. Yeah, so bank voltage needs to be changed to 48. And our daily watt hour use. Daily watt hour use. What was that? It was 4,000. Notice all of a sudden went to negative down here. Okay, now this is, so we know all those things. So we've inputted all that. This stuff is based on output for weather in our area. Okay, that's what we needed to use the PV watts. So we're basically taking a 4 kilowatt array and scaling it to whatever array size we figure out. Okay, so how we do that is let's see, our LG panels, those are 360 watts, right? Can somebody check that for me? 360 watts for LG, the nominal power.
Yeah, 360.
Okay, 360. All right. So it would be wise to do this in multiples of 360, because then you're not going to have half a panel to deal with. And let's say that if we're using our charge controller 150, we did this in the last class. We know that about 3 panels can be put in series. Okay, so let me do a little bit of writing here. So yeah, so is that 360 times 3? Yeah, so 360 watts for each one. So then times 3, you said 1080?
Yes.
1080 watts. Okay, so let's start at 1080. So I'll go back here. So 1080 for the array size first. Okay, so now you look at these numbers here, and once these numbers get below 129, so right here where it says 160, or 116, excuse me, then your generator kicks on. Okay, kicks on, charges it up to about 80%. All right, what is 80% of 430? 344?
Yeah.
I'm going to put that over here so I don't forget. 344. Okay, so 316. So we need to charge this up from 316 to 344. So 344 minus 316. 344 minus 116. You're going to add 228 amp hours to your bank from your generator. Okay? And then it charges up a little bit, and then, oh, look, it's below what we want again. So if I delete this,
okay.
right there, that one. All right, then we go here and we go, oh, okay, 99. So 344 minus 99. All right, then we go here, oh, 65. 344 minus 65. Here, I'll go to the next one. So every time these blue numbers dip below 229, 129. So right here at 82, we go over here, and we are charging from a capacity. So this is how many amp hours are left in our battery bank, 82 amp hours, if we don't turn the generator on. So we're going to turn the generator on, and we're going to charge it from 82 amp hours up to 344. So whatever that is, 344. So we're basically injecting, let's see. We're injecting 262 amp hours. Got to do it again down here. 344 minus 68. Okay, right here is where we've turned on that generator 5 times in a month. And what did it say? It said the customer doesn't want the generator to kick on more than 5 times. And it's definitely going to, because notice you have 1 amp hour left in your battery bank if you don't turn this generator on one more time. Okay. Huh? Right here. Okay. I can explain it.
I did the thing you were doing, and I got at the 31st day, I had 166.
Check your values up here.
Yeah.
Yeah, so let me get into this one more time here. 125. So 344 minus 125. All right. So I turned it on 6 times. Okay. So this isn't what the customer wants. They said keep it below 5. So guess what? You're going to have to add 3 more panels. That's going to be a lot of money for that extra generator kicking on one time. So if it was me making recommendations to the customer, this is what you would say. You'd say, you know, I can do that. But if you're willing to listen to the generator 1 more time a month, at the worst case, I can save you X amount, you know, however much less in panels, right? But since we're just working on a homework problem, we don't care about that. So let's make it actually work. So what we have to do now is we're going to have to double this, right? Because now we can't just add, you know, like 1 more panel. We have to add 3 more panels so that the parallel runs will match. Okay, so now we're looking at what? 2,160 watts? Do that math right in my head? Okay, 2,160. 2,160. All right, now we got to delete everything we did here and start this whole process again. Okay, so now when it drops below 129, so we are right here. Same thing, 344 minus 1.6. Okay, 3 times. 3 times a month it'll turn on now instead of 6. Okay, so I'm sensing that there's confusion, and that's fine because I can talk about it more. So basically what we were doing is, if this is your battery bank, okay, and our battery bank had a capacity, so if this is filled with water, okay, which it's, and by water I mean just the capacity, your storage capacity. It's just easier for me to think about it in like water terms for whatever reason. So if this is filled all the way, that means that we're at max capacity, and that is at 430 amp hours. Okay, 430 amp hours. Okay, but that means we're going to have some usage. Okay, so our battery banks are going to discharge. All right, and basically what it's saying is day over day, here, you're consistently draining your battery bank. Okay, so once your capacity reaches, so we have 129. So down here is 129 amp hours. Okay. Once there's this much left, the generator kicks on and says, no, 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 time to charge it up. Time to fill it up. Okay. Now, I lost my train of thought here. Okay, so here's the thing. Why do we charge it to 80%? That's like right there. Well, the time that it takes to charge this last 20% is basically, it takes a long time for the last 20%. So really it just has to do with efficiency. It doesn't make sense to charge it any more than that just because it takes so long for the last little bit because of the way that the charge controller charges the battery, or I should say the inverter charger charges the battery. So we only charge it up to this 80% line. So that means that 80%, that was this 344 I was using. Okay, so 344 amp hours. So you looked at the blue numbers and they would incrementally kind of go down. And then let's say you got to like down here to 116 amp hours. Now the charger has to go and charge from 116 to 344. Well, what would that be? That basically just means that it's injecting a certain number of amp hours into your battery bank. So 344 amp hours minus, that's an H, amp hours minus 116 amp hours. What is that? Anybody? 344 minus 116. 228 amp hours. Okay, so this number here is what we would add to if these are our columns. Okay, and these are your blue numbers. Okay, over here, you had a bunch of blank spaces, and then you hit that 116, and then you say, oh, time to put in 228 amp hours. Okay, so that's what we were continuously doing. Yeah.
You can explain it afterwards.
Okay. No, that's okay. I'm actually at a good stopping place. Did you have a question?
Why we went from our array size? Why did we double the array size instead of just adding on?
Instead of adding one?
Yeah, just not one panel, but like just one extra row of panels on there.
We could do. We
We
could
got
technically do four.
we started out in the first place. Oh, never mind, that's why.
Yeah, we started with one string. Okay, cool. Good question, though.
Wait, why can't we do 2, 2?
Because it's slightly below the charge controller threshold, the minimum.
Okay.
So the maximum voltage is too low for the charge controller. Yeah.
Is the reason why it's always 344 minus whatever number is there so that it gets up to 344? Because 344 is kind of like the
Exactly.
Okay.
It's like you've got a certain, if I think about it as gallons, you got 5 gallons at the bottom, but you need it to be 10.
Then
5, you're putting in 5 gallons to get to 10. Kind of like that. Okay, so anyway, cool. So basically, if we go back to the original question, because who knows what the original question actually was. I do, but people, I imagine, probably don't, because that was a long, roundabout way to solve. Well, it's really the only way to solve it, but it takes a long time. Okay, so the question was, what is the appropriate array size and orientation to limit generator usage to about 5 times per month for the worst winter month? Now that I read that, and we went through this process, you know that we actually answered all of that, right? Array size would be what? Right. The orientation, we said what? South, 36. Yep. And we're limiting the generator usage to, well, we're doing 3. And remember, we talked about there was 6, the possibility of 6. And that would probably be the best financial decision, but that's not what the question's asking. So worst winter month was January, right? So we answered this question, so that's done. Okay, so the answer the answer is that, what, 22,160 watts. Okay, 2,160 watts.
Okay.
This one. Okay. 6 panels. LG 360, 6 panels. So, next question. About how many hours would the generator need to run during the month? Okay. You're going to get that information from here. Now, how would you do that? We have the information, but figure out how we would do that.
Charge efficiency and how much it needs to run.
So good. Why don't you open up the inverter spec? So the off-grid inverter spec. Not really. So if you go down to where it says charger specifications in your inverter spec, there should be, we're using the MP or the PAE Magnum.
MS4448.
Yeah. So let me pull it up too. Guess I gotta download it. That guy. All right, so this is the spec you should be looking at. We're using this version, the 4448 PAE. If we go down here to the charger specifications, here you have the continuous DC output. So this right here is the current going into the battery. It's in amps. And what do we have here? These guys are, amp hours. So what will we do to get hours? We're going to add these together. So let's sum them up. So sum, because it's asking for per month, how long is your generator running? So I'll add those. Okay, 751 amp hours is what is it being put into your bank. And if we divide that, so if we divide this amp hours by that 60 amps DC, gives you hours, 12 and a half hours your generator is going to be running per month. Yeah. So. Oh yeah, it's the 4448. So this model right there. I will enlarge this. So this one.
Why are we using the inverter? Like, why are we using inverter?
Why are we using this instead of the charge controller?
Yes.
Good question. This is good question. So, let's look at the way that this is laid out again. Let's go to find my, it's just better if we look at the picture instead of me drawing it. Let's see here.
Add those up by
Oops. Okay, that's not what I wanted. This guy. Okay. So the question was, why are we using the inverter spec to figure out how long it's going to take to charge the battery bank? Right. Okay, so let's repeat it so I remember what we were talking about. So here's your battery bank. Here's your generator. This is your inverter. This is your charge controller. So, power coming from, holy smokes, is everyone okay over there? Power coming from your panels goes to your charge controller charges these, okay? Now, right now, we're not talking about that. We are talking about the generator turning on and creating AC power. The current flows through the inverter because you have to go from AC to DC to charge your battery. So when you're going from AC to DC, that is your charger within the inverter, which is different than your charge controller. Okay, so the charger within the inverter, that's what we were reading off the spec. That's what we were reading off the spec. And that is outputting into the battery bank 60 amps DC. Okay? So, if we're trying to find out how long this has to run, amps, okay, you have amp hours that it needs to inject into this. We would therefore divide the amps flowing through here by the capacity that we're putting into this, and that gives us the number of hours the generator will run. Yeah.
correct me if I'm wrong, but I thought we didn't have an inverter unless it was AC power. The generator is AC.
Generator's AC.
Okay, that's right.
Yep. On this side over here, so think of it this way. From this point over here, this is AC. From this point over here, this is DC. Okay. So that is what's going on. Okay. And it is a bit confusing. What I suggest is that if you're doing any kind of design work, look at this picture as you're doing it. Okay, honestly, because that's what I would do, just to make sure. Well, I don't have to do it anymore, but that's what I had to do, because it is a little bit confusing of what is going where, right? So, okay. Now, let's go back to where we were. Okay, so how many hours? We said about 12 and a half hours the generator would need to run during the month, based on what we just designed. Now, it's asking what generator size would be appropriate. Now, this is where we have to figure out what capacity the generator has to be. Dang it. Why am I still in here? Yes. Get out of here. I can see it on my screen, but you guys can't see it on your screen. There we go. Okay. Now, next one says, what size generator would be appropriate? We don't know that. We don't know anything about the generator right now. So what we would do is generator needs to be able to charge like this, charge the battery bank, and power your house at the same time, if that needs to be done. Okay, so it has to have a large enough capacity to do that. So we have to go back up here. So max appliance power draw is 4,000 watts. Okay, it's a lot. So we'll need to make sure that we provide that. And then Let's see here. We also need to go back to the inverter spec. PV watts. Where's my inverter? Okay. And we need to look at so that's going to the house, okay. Then we also need to be able to power the bank. So if we're looking at watts, now I have to remember. I've drawn a blank. Uh-oh, you guys. Finally I've hit a wall. Because I wasn't using any notes. All right. So now I believe we have to go back here. It's a lot of talking. Actually, perfect time for a break. Hey, give me 5 minutes so that I can get my thoughts in order. Come back at quarter after, okay?
Stay right here and bombard you with questions.
Please.
By the way,
Yeah.
those videos you posted after when we were on the boating trip, only like
What did you
20
say?
minutes got
No,
posted.
Really?
Yeah, only 20 minutes and they were the same video.
Ooh.
Yeah, you had part 1 and part 2 and it was the same video and I'm like, okay.
Uh-oh. Okay, I will make sure that I'll go look and see if I just accidentally uploaded the same one twice, because that's probably the last half. And so there's probably a part 1. I hope. If not, then I guess I'll be going over it again in class.
Output of the inverter. Oh, you guys are
Okay.
See?
Can you give me 1 second so that I can look up something really quick?
Oh, did you? Oh, you didn't add these numbers in?
Did you add it in the phone? Yeah, I don't have this thing. Yeah, but I don't get this one.
Yeah, that's fine. That's where you want to start on this number.
Yeah, I don't have
And you get one fifty. And then you take 344 minus that number.
Where are you going?
Probably gonna go out.
Actually,
One play. And then you do the same thing. 44, what is that number?
Tomorrow, Saturday, Friday, and then Saturday, Sunday, right? Monday's done.
Right. Science goes out in the hallway, triple for a professor.
fuck. Freeze over. I need it all.
When you.
All permanents tied to whether you are all non-way. That was all permanents.
Okay, they're starting again. You shot me.
Just because I got my key.
Oh, that's pretty cool.
The one to come, what's the door?
Oh, I do.
Maybe this is
Don't go together at all.
Life doesn't matter.
That's my dinner. Everybody's like, oh, yeah, I don't have kids.
Hey, the lower you go, the lower it helps you more, the more the six. We were like on the way to Boeing. I went to go pick your number in.
You literally said.
I just have trash.
That's what I'm searching there at.
That's
America.
my social media right there.
American.
So,
It's
Yeah.
American, not
Essentially, the
American.
gold standard.
Christian American.
Flights.
They're different than American.
No.
Huh?
But it's like.
I don't know. Just know the
It's
best.
fun. Yeah.
I'm so.
You should look in the mirror. Just make you more uncomfortable.
Long time no see.
Oh yeah. Okay, I remember now. Ugh.
See this Chad from.
All right. Did you have a question for me, Sonia, or did you figure it out?
So yeah.
I think we're going to see this, right? 4%.
None of you were. I have.
Shade.
Oh, that's the worst.
Remember?
So
You were
sometimes
wearing
we
life
can
jacket on
just
those?
take that volume times.
Yeah.
I can say something
I wear like
to
that
you,
one
but I
all
figure
my
I might as well
stuff.
just break
Also, you should wear a life jacket.
Yeah.
Jumper cables.
Alligator clips.
They're not the same thing.
Depends on how high current you're gonna.
Honestly, I think that's kind
Low
of
current.
suboptimal.
Low current. high
So my
current.
problem with that is suboptimal is tap work. Tap and like bouncing more things into it was suboptimal because tap is higher power.
I wouldn't know.
Yeah, I can imagine though. What else would you do? Like, what would you do then?
But honestly, I think
I think I found These two are. What are you doing? Use the hospital and you're like,
Yeah,
that's
like,
just shit.
Dude,
You're
they're
like,
just seeing the crazy.
oh,
This one.
I got it. Just like the kids.
5 hours?
Someone's
Someone's doing that. Someone got like 4 stuff.
One of my boys like that. My
Was that you? Well, they just,
there's like, I've
they just
seen
figured
like.
it's small. I just figured it probably was.
No, I think it's like to stop.
2 points wasted. I didn't use your rating like that. I could have the whole.
Sorry, so I haven't done that yet.
My buddy.
No, it's just like, it's just like,
hot shit.
I'm like a
Oh,
computer.
hey,
It's
you
just
are
like-
on your dog. Oh, dude, you would get 30 tickets. No, side to side. First of all, it should be a
I just wait to get the water out.
Yeah, and
Why do you?
Because I've never done it myself.
like that, I get.
So, I had to-
What?
When you get like in your area, you get like issues.
No.
Then it's time.
Maybe. You get a negative.
When I, like, honestly, when I clean my hair,
You like rinse it or no? But I just get out of the shower. So.
yeah, exactly.
I don't know, the washing machine after you use them.
Dishwasher.
I watched, I saw it. It's gross. But then I got the comments. Because I was like, what are people like saying it's weird? And the one server that doesn't do that. And then everybody's like, wait, you're supposed to like, you're not even supposed to put it in your ear. Yeah. No. I really want to do the thing where you light it. Because like the I use that. It's not like a John. In Japan, they use Q-tip. They use the earbuds.
Oh, that is how you work.
Yeah, so, oh, you gotta be careful because it's like, the thing usually goes around.
Okay, remember when I was all right.
Do we have to go back to learning?
I had to go back to learning, but you are. Oh.
Do you wet the Q-tip before you use them? This was a topic.
this morning? No.
Okay, that's what I thought. Oh, wait. We're not at the whispering here.
How about let's keep going? My gosh. Okay. Yeah.
Were we on what size generator was?
Yeah, exactly. We are on what size generator is appropriate. Okay. So like I said before, gotta have our battery bank charged and our generator charges it. It also charges it also powers our house. Okay. So we know that we got 4,000 watts going over here. All right. And then we need to go back to our inverter because remember, this goes through the inverter from AC to DC. Okay, so if we go back to our inverter spec sheet, which I have right here, we are going to multiply our current AC, so 17.5 by 240. Can someone do that for me?
4,200.
17.5.
By 240. Or 240 volts. So amps times volts.
4,000.
There you go. 4,200. So we got 4,200 watts going over there. So that means that our generator has to be, as far as, capacity, 4,200 plus 4,000, 8,200 watts. Okay, so now that is the answer to that question, 8,200 watts. And if you wanted to go further with that, which you would have to in your project, you have to actually find a generator that will fit that. Okay, so you could go to Lowe's website, go to Home Depot's website, and find one that has that capacity. In addition, you want to make sure, like say if you have that Excel sheet with the different loads on it, like what we filled out last week with your dishwasher, your fridge and all of that. You want to make sure that your peak, meaning your surge load, so your watts, when you add them all together, that your generator has that surge capacity, and that would be on the spec sheet. So let's find a generator. Since we're here, let's just do it. So yeah, generators RS. I'm gonna go to Home Depot's website. Yeah, Harbor Freight. Here. I think dual fuel would be kind of nice. Let's do that one. Oh, okay. So here's one 1200 watt. That'd be plenty. 8,000 watt. That'd be all right. Maybe. Here we go. Westinghouse. 9,500. Sure.
How efficient, like, is this compared to using the energy from the grid? Like,
How efficient?
What footprint is it? The carbon footprint.
You mean to turn on your generator versus the grid, just tie into the grid? You would have to do some serious analysis, I think, on that, because you'd have to figure out where your power is coming from, first of all. Now, okay, here's a good comparison. If you live on the East Coast and they use like coal still, this is going to be way less of a footprint. If you live here and it's hydropower, maybe not. That would be my anecdotal assessment. Okay, so let's see here. Let's see if we can find the details. Where are the where are the specs? Specs. Print.
I have a question.
Yeah.
A generator like that is usually
Specs.
meant for extended use, like, you know, 12.5 hours at a time. You probably have to refuel it multiple times. They do have them that are made for extended use with a much larger fuel tank.
So they're not going to be used 12 hours all at once, because remember it turns on 3 different times. So you could just go fill it up. But you can see that engine displacement, dual fuel. And when I say dual fuel, it'll run on propane and gasoline. And if you think about it, that could be good, because what if you were using propane to cook with if you're out in the forest or something? But then at the same time, you want to be able to run it off of gasoline and in a pinch or something. So
You could get a giant propane tank to get a hospital.
I know.
Dad didn't know the size he was supposed to get, and it was like 3 years before he had to refill it. And that one is like,
That's so funny.
But, my friends, they have theirs for the generator. That's all it is a giant one that does the barbecue and the generator. He filled it up once 8 years ago. It's never.
That's awesome.
Mistakes were
Generator one turns on when they power up.
Back when they made propane good.
That good propane. Okay, so here's an important thing to note. All right, running wattage 7,500. Okay, that is slightly lower than what we want, so we may want to look elsewhere. But the other thing you want to look at is your starting wattage. So starting wattage is talking about surge. Okay, so that is how much it can produce to cover starting load. So remember, surge is when you turn on your motors and they require higher power, and then it dips and it evens out. Okay, so
that is the protection. 2,000 is the protection against surge.
Yes.
That this generator.
Correct. Yes. Now let's go back to where we were. So that's how you would kind of choose a generator. Another important thing to look at, which I don't know if they have it here in the specs, they sometimes do. Gas mileage. Well, you'll need that. You will need that, right?
It's 0 because it's probably not moving.
Well, yeah, but you need to know how much gas you're going to use, because you have to know, you have to budget out how much you're going to pay every year.
So like watts per gallon, what is that in?
it's gonna be
Miles.
Gallons.
it's gonna be gallons per hour.
Which for this generator is 1.7. 1.17.
Yeah.
No replacement for just.
All right. Here's the other thing: operational volume. How loud is this thing, and how close do you want it to your house?
Put it in the house.
That's a pretty slow.
I'll have to light shut it up for too long. Put it in your neighbor's yard.
73 decibels.
How loud is that? Pretty quiet.
I'm gonna look it up because I have no idea. I don't have a good.
Get an electric generator.
Bird calls 44. I like these comparative examples. What is this? I don't know what that's about, so no thanks. Volume of a vacuum cleaner at 1 meter. Okay. So pain begins at 125, just so you guys know.
Chamber music.
Vacuum cleaner, chamber music in a small auditorium, telephone dial tone. Okay, so not that loud.
Louder than you really want to.
It's, yeah, I mean, you're only running for 12 hours a month, so, but is it going to kick on in the middle of the night? All right, so let's go back where we were. Okay, this is something you guys can do without me. Number 4, what is a workable configuration of the resulting array? And what are the max VOC, max ISC, and realistic operating values? You love that. Okay, I'm going to let you do that on your own.
So what should I put for what size generator?
8200.
Okay.
Yeah, 8200.
Now, you can do number 4 on your own. And then let's do the wire sizing. So we already kind of know that we have 2 runs of 3. Okay, we kind of figured that out already. So that means that we need to find the maximum current, so ISC, for 1 run. Can you guys do that for me? Maximum ISC, meaning what? Highest temperature, although it doesn't really change that much with temperature. But you're going to use those equations that we went through.
How do we know if a generator is set up to be able to start automatically?
You'd have to look probably in the specs, and if not, then I think you can get an automatic starter.
What were you looking for?
The max current.
Do you already have the answer?
No.
Oh, wait.
After you're done with that, no, I'll do it. I'll do it with you guys. Never mind.
Ten point nine two nine.
7.929.
10.9.
10.929. That makes more sense. Okay. Yep. 10.929 amps. Okay. Now, the other thing we need to, so on your own, you can do the other parameters, okay? Because you guys know how to do those all. But let's look at the operating power output. Okay, so WMPP at a certain temp, which is 25.49 C, because that is going to be the lowest temperature if we actually convert it. 25.49 degrees C. Okay. And then we have, how many modules do we have? 6? 6 modules times our, that is from our 0 degrees Fahrenheit. We need to change it to Celsius. Oh, that's not right, is it? No. What is it? Can you do that?
17.7.
Negative 17.7. Okay. Let's do that. Negative 17.7. Okay. 6.
Like right in the middle of the 0 degrees. and 85 degrees.
Uh-huh. Yeah. Well, that actually, no, that's why we did that. That would be at on operating temperature. So that'd be like room temperature.
So 62.
Yeah, do 62 degrees. 62 or 70, some kind of like in between the max and the min temperature.
So 65.
Okay.
18.3.
18.3? Okay. Okay. Not negative, right?
That is 65 degrees Fahrenheit or 18.3 degrees Celsius.
Thank you. All right. 18.3 degrees Celsius. So then we have our WMPP from our module. So that's if you go to this spec, the NOCT, power rating. Can somebody look that up for me? So the LG panels.
So, you know,
Yeah, for NOCT.
271.
Okay, 271. 271 watts, excuse me. All right, and then we need to have the temperature coefficient. What is the temperature coefficient for power? 0.00 something.
For power,
Mm-hmm.
0.0037.
37,
Or
okay.
negative 0. Yeah.
Yep, like that. And then we have our 18.3 minus 20 degrees, which is our reference. Okay, so does somebody want to do that math for me here? See what our watts are?
$16.36.
1636 watts. Okay, so that sounds about right. That works. That actually does sound pretty good. Okay, cool. So now what we need to do is, if we go to question 5, where it says, because I'll let you finish the one before that on your own. Yeah, so right here, if the array is located 200 feet away from the charge controller and power loss for the resulting cable were to be no more than 3%, what size wire is needed and what would it cost? This is very important. Okay, so as far as conductors, what do we have to think about for conductors? There's something that happens if current goes through them.
They get them.
Resistance, and there's loss through heat, right? So we have to figure out which size will basically be conducive for the current at different points in our system. So it's saying we don't want to lose any more than 3% of our power, okay? And our power is what we just found. Our operating power is like that, whatever I said, 16, whatever Dylan said, 1600 or so, okay? So it's asking, okay, if we don't want to lose more than this 3% of our power, what size wire do we need? If a wire gets bigger, is there more or less loss?
Less.
Yeah, less. Because there's less resistance. Now, and bigger, I mean, as in larger diameter. Now, as the wire diameter gets larger, what else gets larger? Cost. Right. So we don't want to oversize too much, because if it's 200 feet away, we have a positive and a negative lead. So that's 2 runs really of 200 feet. And so if you have a very expensive wire, then that doesn't help your bottom line. So
It has a ground too. That's not have.
what's that?
It does not have a ground as well.
They have grounding too, but they don't have the ground. They ground the components, not the ground run. It's going to be different wire. So, okay, so, all right, so let's keep going here. So if we use this number that we just found, so we have to find the wire size, 1636 watts. We want to know how many watts we can lose. So we're going to go ahead and multiply this by 0.03. That's our target loss. We don't want to lose any more than 3%. So if we do that multiplication, let's see. 49.08. Yep. 49.08 watts. So we can sacrifice those watts, okay, up to that amount. Okay, now let's try and figure out what our resistance is. So our allowable resistance. So R is equal to power over current squared, which for us, our power that we're going to be okay with losing is 49.08 watts over our current, the ISC current that we just found, 10.929, 10.929 amps, square that. Okay, so now we got to figure out what that is. 49.08 divided by 0.411. Like 6, which a lot of decimal places. So now that is this in ohms? Okay, for both wires. Now we're getting to a certain point. Now we need to be able to look at wire tables, and so we need to put it in the correct unit to compare it to some wire tables, and that needs to be in ohms, milliohms per foot. So we're kind of getting to that point. Right now we have ohms. So how many feet are we running? How long? 200, 400 though total. So 400 total, there and back. So 0.4116 ohms over 400 feet. Okay, so now we have an even smaller number divided by 400. So now we're looking at 0.001028, real small there. Okay, 29, I guess I should say. Okay, and now this is in ohms per feet, but really, feet. It'd be better if we put this in milliohms per feet, so 1.029 milliohms per foot. Okay, so now we can use this number. We're going to go to, and honestly, I just go to Wikipedia. That's fine. This time, that's fine. We're going to go to American wire gauge, Wikipedia, American wire gauge. So we need to go down to the wire table here, wire sizes. So notice resistance per length, milliohms per foot right here. So we have what did I just say? 1.029. Okay, 1.029. So all the way down here, 0.029. So we want to have less ohms, less resistance per foot if possible. So instead of going to the 1.2, we'd go up to the 0.99 right here. Yes.
How expensive is wire that can cover this?
How expensive is wire? Well, you can, so this is small wire, but if you look up the bigger wire, which would be like 4/0, 4/0, that gets rather expensive. Let's see. So we can look it up right now. It's real big. So 4/0 wire. So, whoa, what happened?
Press back.
Okay, so, oh shoot.
If you keep
I think it's, yeah, I think you're right. There we go. 4/0 wire is $4.25 a foot.
That's pennies if you steal it.
It's pennies if you steal it. It's a lot. So, I mean, that's a giant wire. It's not like you're going to put that in for 200 feet. Well,
Is that what they use for power cable?
that is what they use for distribution lines. So, for example, if you want to have your power tapped off of the lines residentially, they would use between 1 and 4/0 typically. And that's actually what I used to do back before I did this. Okay. Anyway, so just to give you an idea versus, number 10 wire. So 800 feet, that's a lot. 500 feet, $90. So much less. Okay, so let's go back to what we were doing here. And the other thing that we have to check, so if I go back to Wikipedia here, American wire gauge, and let's say I've got 10 gauge here, 10 gauge wire. The other thing we need to check is we need to check the ampacity. Ampacity means the amps flowing through our wire. Is our wire able to handle that? And right here at 60 degrees C, 75 degrees C, 90 degrees C, the number 10 wire can handle 30 amps, a little hotter, 35 amps, a little hotter, 40 amps. Okay? So, if we have, so let's see, you had, how much current do we have going through that guy?
10 point
10 point something.
10.929.
You know what though? I thought this looked kind of funny. Just think about it. Oh, we're almost out of time. We're gonna have to go back and change something here. Well, let me do it real quick. Give me 2 minutes. Okay, so if you think about it, we just found, remember I had you do the ISC? The ISC, the current going through this? Well, remember, we've got 2 runs. What does that mean? If they're in parallel? Times 2. 2 times our amps. All right, so that means we gotta go back here for a second. That means instead of 10.92, we're looking at about 22 amps. Okay, 22 amps. Let's redo this. 49.08 divided by 22, divided by 22. Okay, so now we're looking at, and you can tell me if I'm getting a different answer than you guys. 0.114. Then this one goes to the same.
0.1027.
I have 1014, but I rounded this. That makes more sense. 0, 2, 5, 5, 0.25. It's been 2 minutes. Ding, ding, ding. I'm out of time. So I got about 0.254 milliohms per foot, roughly. Okay, go back to my wire gauge. Now look at how big of a wire I gotta get now. We're up at like number 3. Okay, and we should be fine with our ampacity because we are going to be putting about 22 amps through, which is way less than 85. Okay? So, but you do want to check that just to make sure.
So where does 22 come from now?
Because I realized that we had, I realized that when you did the ISC, you were just doing it for one run. And remember, we have 6 panels, 2 runs of 3. So we needed to multiply that ISC by 2, which is roughly 22. Okay, guys, get out of here. I kept you 2 minutes over.
6 panels and 2 runs?
Yeah, 6 panels, 2 runs, 3 panels in series.
I just have one. Hey Noah, I've been asked multiple times today.
And so we just looked up the cost.
Hey Noah, is that
And are we going to work on this on Monday?
I don't even know my class. We'll finish it.
Okay.
We'll finish it, and I'm not sure what else we're gonna
Okay,
do.
so don't like try to get all those classic. Well,
Do up until this point
The one that you told everybody.
that they had to do it on their own.
fail.